Welcome back to physics classes. Now I am repeating Newton's second law of motion. Again, you see. So what Newton's second law of motion states? We will be seeing. Newton's second law states that the rate of change of momentum of an object is directly proportional to the unbalanced force and acts in the direction of applied force. So, we know what is momentum. Momentum is the quantity of motion produced in a body. So, the quantity of motion is represented by T is equals to mathematically product of mass into velocity. Now in this case, force is directly proportional to the rate of change in momentum. That is, when it started, the object initial momentum is mu, final momentum is mv, change in momentum is final momentum minus initial momentum, and rate of change is final momentum minus initial momentum by t. Since that is mv minus mu by t. So common, make m common. So m into v minus u by t. So v minus u by t is equals to acceleration from the equations of motion, from the first equation of motion, or by definition of acceleration. Acceleration is rate of change of velocity, that is v minus u by t. Substitute the value of a. So F is directly proportional to ma, and in order to remove the proportionality constant, F is equals to kma. In honoring Newton, we have given SI unit as Newton. Now you have observed this video, no? What happened? Force applied by Newton is very less rather than force applied by the horse is more. So less acceleration is produced when Newton moved, whereas when horse moved, that more acceleration is produced. Hence, force is directly proportional to the acceleration. F is directly proportional to A. Now, whose force is more? Horse force is more. Now, force is also directly proportional to the mass. Mass of Newton is less, so applied force is also less. Whereas mass of horse is more, applied force is also more. So F is directly proportional to mass, and F is directly proportional to acceleration, and F is directly proportional to the product of mass and acceleration. Hence, F is equals to kma. Hence, and K is proportionality. Next, Newton's third law of motion. For every action, there is equal and opposite reaction. To every action, there is an equal and opposite reaction. That means action force and reaction forces are equal, but they act in opposite direction. This is Newton's third law of motion. For every action there is an equal and opposite reaction. Now you observe this video and create your own story.
our body exerts downward force on the chair and the chair also exerts upward force. See how birds are wings are exerting downward force, and in opposite the push of the body air in opposite direction to the bird. So action reaction forces are equal.
Now, coming to the conservation of momentum. By definition, the total momentum is conserved. The total momentum is equivalent to zero if no external force is acting on it. That means the total momentum of a system before collision is equal to the total momentum after collision. So we will be considering here two balls. Let it be A and B. A and B. Ball A and B. Consider two balls, ball A and B. So change in momentum of body A is M1 V1 minus M1 U1. Then B is M2 V2 minus M2 U2. Now F is equals to minus F2 minus F. That is A is equals to minus B. That is M1 V1 minus M1 U1 is equals to minus of M2 V2 minus M2 U2. Now you bring all the identical terms towards one side. That is, we will be taking see M1 B1. This minus into plus is minus. So coming this side it becomes plus. M2 P2 is equals to minus into minus plus. This minus coming this side is becoming plus. M1 U1 plus M2 U2. Now interchanging the terms. M1 U1 plus M2 U2 is equals to M1 V1 plus M2 V2. This is known as conservation of momentum. Again, see, ball A momentum, change in momentum, ball B change in momentum. According to Newton's third law of motion, action is equals to minus reaction. Here ball B is minus, reaction A is action. So change in A1 is M1 V1 minus M1 U1.
whereas change in momentum of the ball is minus m2 v2 minus of minus m2 v2 minus m2 u2. Now bringing the identical terms m1 v1 minus into plus minus only, but coming this side it becomes plus m2 v2, whereas this m1 u1 plus this coming this side, this becomes plus minus into minus plus, so m1 u1 plus m2 u2. Now so changing the terms, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. This is called as, now total momentum before collision is equals to total momentum after collision. This is nothing but the conservation of momentum. That means total momentum will be conserved in a system. Now last end is known as recoil of gun. What is, now consider mass of the gun is m, mass of the bullet is small m, velocity of the gun is v, velocity of the bullet is, see before collision is after collision we are saying. So before the system is starting, that will be initially before shooting, total momentum of the gun will be, total momentum of gun before shooting is equals to 0. Now after shooting is, what is total momentum after shooting is equals to mv plus mv. Now this is equals to 0. Now conservation of momentum, m according to conservation of momentum, mv plus mv is equals to 0. Now recoil of the gun is v, capital V, v is equals to, this goes that side, minus mv by m. This is called as recoil of gun basing on the conservation of momentum. So this you can write like this also, v is equals to, this can be written as like this also, v is equals to minus m by capital M into V. This is recoil of gun basing on the conservation of momentum. Okay, this is the last part of the, so rocket propulsion, then inflated balloon lying on the sea. Example, one more, conservation of momentum. Suppose one balloon is inflated during birthday and all, you will be inflating the balloons and keeping lying on the floor. Suppose you prick a balloon, what happens? The air comes as jet in the backward direction and the balloon moves in the forward direction. These are all examples of conservation of momentums. So recoil of a gun, what we have considered, basing according gun mass is big, no gun, so M, capital M. Bullet mass is small m. Velocity of gun, before is V only, after V, before velocity will be U, 0. So total momentum before shooting for the gun is 0. Then so final momentum for the gun is mv, bullet is small m, small v. Now total momentum after shooting is mv plus small mv, momentum of the gun plus momentum of the bullet, which is according to Newton's conservation of momentum, mb plus mv is equals to 0. Now recoil of the gun, v is equals to This when it goes this side minus mv by this is multiplying, so division by m. Now only m's, or v is equals to m by m minus of m by m into p. This is all force and loss of